In this video, we will discuss the fundamentals of aircraft weight and balance, focusing on how to calculate the empty weight center of gravity, loaded center of gravity, percent mean aerodynamic chord, and CG shift. These calculations are essential to ensure that an aircraft operates safely, remains stable in flight, and stays within its allowable limits. Understanding these concepts helps aircraft mechanics and pilots maintain proper loading and overall flight safety. We have 4 EWCG formulas. The first two are for nose-wheel aircrafts, while the other two are for tail-wheel aircrafts. Each formula has their own purpose, so we must fully understand or analyze the question before we start using a formula. For example, Formula 1, it is only used when a nose-wheel airplane has a datum that is forward of the main wheels. And Formula 2 is also nose-wheel aircraft, but the datum is aft of the main wheels. D is the distance between datum and main wheels. F is the weight of the nose wheel. R is the weight of the tail wheel. L is the distance between main wheels and nose or tail wheel. W is the total empty weight of the aircraft. These will be our sample values. For this example, we will be using formula number 1. Let's first write down our given values. D is 320 inches. F is 9,200 pounds. To get the distance of the main wheel and the nose wheel, we will subtract the arm of the main wheel and also the arm of the nose gear. The value of our L is 230 inches. To get the total empty weight, we will add the weight of the main gear and the weight of the nose gear. The value of our W will be 36,000 pounds. Now let's solve our EWCG. After calculating the empty weight CG, it will be 261.22 inches. The arm we will be putting in the empty aircraft will be this EWCG. These are the weights that we will be using for the table, such as 360 pounds for the pilot and the co-pilot. Since our fuel is in gallons, we will multiply it by 6 so we can convert it into pounds. We will also convert oil into pounds by multiplying it by 7.5. The weight of the empty aircraft is the nose wheel plus the main gears combined. As I mentioned earlier, the arm of the empty aircraft is the empty weight CG we calculated. The arms of the crew, fuel, oil, cargo will be found in the TCDS. Since our arm for the compartments of the cargo is arranged and not a specific number, we will get the midpoint of each station that we need. To get the midpoint, we must add the forward limit to the aft limit and divide it by 2. After writing down all the values in the table, we must now find the moment by multiplying weight to arm. For example, 36,000 times 261.2 is 9,404,000 500,000. We will continue this until we finish the table. After doing so, we will now get the total weight by adding all the weights of the items and adding all the moments to get the total moment. We will not add all the arms to get the loaded CG, as this changes the value of the loaded CG. In adding all the arms, you will get a big number of loaded CG, and this will affect your calculation. To get the loaded CG, we must divide the total moment to the total weight. The loaded CG will be 292.6038702 inches. This again is the table for your reference. Our CG is not within limits. Since our weight is 52,710 pounds, this weight is above 40,000 pounds, so we will be using letter B. We will disregard the values in letter A since our total weight is not below 40,000 pounds. Our CG range is 313.4 inches to 324.4 inches, while our loaded CG is only 292.60. After computing the loaded CG, we will now compute the percent Mach only if it is applicable to the aircraft, because some aircrafts do not have this in their TCDS. This is our formula in calculating the percent Mach. The second formula is a derived version of the first formula. It is used when we are computing for the CG. These are the values I have written down in the given, and the CG is the loaded CG we have calculated earlier. We are solving this percent Mach to ensure that it is within the percent Mach range. The percent Mach is equals to 10.35, which is not within the limits. The percent Mach range is 23% to 29.7%. As you can see, our current percent Mach is below the percent Mach range. Therefore, we need to make corrections in this next step. After writing down the given values from the TCDS, we will now solve for the CG. The percent Mach we will be using is either from 23% to 29%. But for this example, I will be using 23%. You may choose whatever percent Mach as long as it is within this range, or as long as it is within the range of the percent Mach given in your TCDS. Using the 23% will allow our final CG to reach the percent Mach range given in our TCDS. If we use the 10% we got previously from the percent Mach computation, our final CG will be less than the allowable limits. This part involves some trial and error since you will be choosing your own percent Mach within the range until your CG calculations reaches its allowable limits. After making some corrections, we can see that our CG is now within the range. Now that our loaded CG and percent Mach are within the range, now we can proceed to weight shifting. Here are the given values that I have written for the weight shifting process. The uppercase W is the total loaded weight that is from our table. The change in CG is calculated by subtracting the CG from our percent Mach and the CG from our loaded CG. After subtracting, our change in CG will now be 20.78363 inches. Since our loaded CG is less than the CG range, we will need a bigger moment. To get a bigger moment, we will have to move the cargo from the forward compartment to the aft compartment. In this case, compartment C to compartment J. This distance the cargo has moved will be the value of our letter D. In order to get the distance, or the D, we must subtract the arm of compartment J to compartment C. To calculate the weight shifted, we must derive our values. The value of our weight shifted will be 2,580.695,259 pounds, or this is equals to 2,580.70 pounds. This weight shifted is the amount of pounds that has moved from the compartment C to compartment J. Here in the TCDS, the capacity of the compartment J is 2,800 pounds and the weight we are shifting is only 2,580 pounds. Therefore, the cargo we have shifted in order to balance our aircraft is within the capacity of compartment J. Here is a way of checking if your values are correct. Since we have moved cargo from compartment C to compartment J, we will subtract 3,000, which is the old weight of the compartment C, to the weight shifted. That will be the new weight of our compartment C. We will add compartment J to the table since we have moved it there. So we will put 2,580 as that was the weight we shifted. When we get the final CG of this new table, we will get 313.38, which is equals to 313.4, and it is now within the limits. In conclusion, understanding weight and balance is essential for safe aircraft operation. By accurately calculating EWCG, loaded CG, percent Mach, and CG shift, we can ensure proper stability and performance. I hope this video was very informative. Thank you for watching.